Hi, my name is Kian Charles Borja and this is my CLI-based Python application project. My project is called the Past Electricity Bills Tracker, a command line application that lets you record, organize, and analyze your household electricity bills using tiered pricing, thread tracking, and tag-based searching. Nowadays, there is a lot of concern about how the electricity bills went 2 times higher than the previous bill. That's why I created this project to look back at their electricity usage history, spot unusual spikes, or understand exactly how their bill was calculated. This app fixes that, all from the terminal. No spreadsheets needed. Let me run the app and walk you through everything it can do. When we launch the app, it greets us with a welcome banner and asks for the account holder's name. I'll type my name here. The tracker is now initialized and ready. You can see the main menu with 7 options. Let's start by adding our first bill. I'll choose option 1. The app calculates that we use 150 kilowatts per hour, applies the tiered pricing, the first 100 kilowatt per hour at 850 pesos, and the remaining 50 at 12 pesos, and give us a total. The bill is confirmed and added. Now let me show you how the app handles bad input. I'll try entering a current reading that's lower than the previous reading, which will be physically impossible. The app catches this and prints an error. Current reading cannot be less than previous reading. The bill is not saved. This is handled inside the meter class. Let me also show you what happens with non-numeric input. Python raises a value error, and our try except block in the CLI catches it. No crash, just a clean error message. Option 2 lets us view all bills. We can sort them out in 4 ways: chronological, highest cost, lowest cost, or highest kilowatt hour. Let me try sorting by highest cost. The bills are now reordered, with the most expensive one on top. This uses Python's built-in sorted function with a lambda key. Option 3 gives us a full summary. Total bills, total amount paid, averages, the highest and lowest bills, and all tags used across every entry. Everything is computed on the fly from the bill data stored in memory. Option 4 is one of my favorite features. It compares each bill to the one before it, and it shows whether your electricity use went up or down, and by what percentage. You can see arrows indicating the direction of change. This is great for spotting seasonal patterns or months where usage spike. Option 5 breaks down exactly how each bill was computed using the two-tier pricing structure. For bills under 100 kWh, it's all Tier 1. For high usage bill, you can see exactly how much fell into each tier. Option 6 lets you search by tag. Let me search for all bills tag summer. It finds and displays only the matching bills. Tags are stored as Python sets, so they are always unique per bill. Let me walk through the class structure. I designed this up around 3 classes, each with a clear responsibility. The meter class. The meter class is the simplest. It takes a previous and current meter reading and has 2 methods: get kilowatt hour used to calculate consumption, and compute bill to apply pricing. It has no idea about billing periods or dates. It just does math. The bill class. The bill class represents one electricity bill. In each constructor, it initiates a meter object and uses it to compute kilowatt hour use and total amount. It also stores a tags attribute. And notice I use Python set here, which automatically prevents duplicate tags. The bill tracker. The bill tracker class. Bill tracker is the top level manager. It holds a list of all bill objects, a dictionary mapping billing periods to amounts for quick lookup, and a set of all unique tags used across all bills. It owns all the major operations: adding, viewing, summarizing, and searching. This is the most important algorithm in the app. Electricity in the Philippines uses a two-tier pricing structure. The first 100 kilowatt hour is charged at 850 pesos per kilowatt hour, and anything beyond that is charged at 12 pesos. The logic checks if kilowatt hour is within tier 1. It's a simple multiplication. If it exceeds 100 kilowatt hour, we compute tier 1 separately as 100 times 850. Then compute tier 2 as kilowatt hour minus 100 times 12 and add them together. This mirrors how real electricity bills are actually calculated. Here, I use the list comprehensions, an advanced Python concept, to extract values from all bill objects in clean, readable one-liners. Instead of writing a for loop and appending to a list manually, these two lines iterate over every bill and pull out just the field I need. Then I pass those lists directly into sum, mean, max, and min. I also used a list comprehension here to filter bills in one line, returning only the bill that contained the search tag. This is concise, Pythonic, and very readable. To wrap up, let me reflect briefly. Most challenging part. The most challenging part was designing the class relationship correctly. I had to decide, should meter be separate from bill or should they be combined? I kept them separate so that the meter calculation logic is isolated and reusable. It also made error handling cleaner since the meter class handles reading validation independently. What I would improve? If given more time, I would add data persistence. Right now, everything is lost when the program exits. Saving bills to a JSON or CSV file would make this genuinely useful for a household. I'd also add a monthly comparison chart, maybe using a simple ASC bar graph, so users can visually see which month was the most expensive at a glance. Thank you for watching. This has been my demonstration of the past electricity bills tracker.